Polynomial long division can give students issues. Polynomial long division is just taking one polynomial function and dividing it by another. It really is similar to regular long division, except that now you have variables. Let's do a quick example of a regular, and this is going to seem incredibly silly, but let's just divide 213 by 4 and see what happens, because the steps are very much the same when doing it with polynomials. So if I take 213, I know that that's going to be divided by 4. I look and say, okay, how many times does 4 go into, 2? 4 doesn't go into 2, but 4 will divide into 21, and that'll be 5 times. Then I do 5 times 4, and that gives me 20. Then I subtract the whole thing. I subtract the 20 and end up with 1. I bring down the 3. Now I say, okay, 4 goes into 13 how many times? 3. Then I get 3 times 4 is 12. I subtract there, and I get a remainder of 1, or I can write it as 53 and 1/4. For polynomial long division, it's pretty much the same setup. I'm going to put, I know that 3x to the third plus 4x squared. You notice there's like a 0x in there. This is actually a placeholder. So we need to know, we need to make sure that we have from high power to low power the polynomial written out, and anywhere where there's missing, there's like a 0x squared, or in this case a 0x, I put that in, and we'll see it as we move along that that's really crucial. And then minus 1. And divide by that by x plus 5. So just like regular division, I want to see how many times, in this case, the x goes into 3x cubed. So let's see, I have 3x squared. 3x squared times x gives me 3x cubed. You don't have to do this, but what a lot of students find useful is to say, okay, I'm going to take that 3x squared times x plus 5. And I have to write that over here. So I get 3x cubed plus 15x squared. Now I'm going to subtract the whole thing. That's where in part that Alex explains, I think they could show a little bit better. You don't just subtract the first term, you're subtracted that entire expression. So I always put parentheses, and then what I'll do is say, okay, well, the first term goes away as it should, so there's 0x cubed left. Now I have 0x cubed. The negative also goes to the 15x squared. So now I have 4x squared minus 15x squared, which leaves me with minus 11x squared. I have to bring down the plus 0x, because the next step is I say, okay, I have my x, I need to get to negative 11x squared. What do I need? In this case, I need negative 11x. At this point, the process is iterative. In other words, it repeats. So I'm going to have the negative 11x times the x plus 5. So I'll end up with negative 11x squared minus, let's see, so that went there, 55x. Once again, I'm going to subtract the whole thing. If you add up this column with the negative 11x squared and add another negative 11x squared, you'll end up with negative 22x squared. But remember, the whole point is to get rid of those. So now I'm going to distribute the negative through. So that becomes positive. This becomes also positive, so I have 55x, and then I'm going to bring this down, minus 1. X times what gives me to 55x? Well, it's plus 55. So I'm going to take the 55 out here, as I've done before, do x plus 5, and I'm going to get 55x plus, let's see, no shame in saying I'm just going to do this off the side here. 55 times 5 gives me 25. 25 plus 2 gives me 275. Now remember, I'm once again going to subtract the whole thing. So in this case, this becomes negative, so the 55x's go away. That becomes negative, so my remainder is negative 276. You also could write it as 3x squared minus 11x plus 55. And just as we did in the regular example earlier, we can put the negative 276 on top and the x plus 5 on the bottom, like we did in the previous example where we put the remainder of 1 on top, and the 4 on the bottom.